Hello, welcome to Tech Dictated. I am Doreen Shamweno and today we are looking at pseudocodes. So I decided to talk about pseudocoded flowcharts because, I believe they are important when you're just writing down and figuring out how a certain algorithm or a certain piece of code should look like and how it should run, and when you want to just test it out and figure things out, how something works. And dry running, if you would like to do that, or you can, if you prefer doing it on code, that's still fine. But whichever the thing you're doing, it's always good maybe to just write a bit and just see everything before you start coding. Yeah, so that's my view, and so that's why I'm talking about pseudocodes and also flowcharts, though I don't think I have ever used flowcharts, but I have used pseudocodes more often. So pseudocode is just a term that tells you pseudo means false and code is code. So false code. So you've not really written in a certain programming language, but you've just jotted down how the logic flows, how everything works. Yeah, basically that. We're going to look at an example later on. So it's just a way for you to represent how you will implement a certain piece of code or a certain algorithm or whatever it is you're doing. Yeah, so oftenly you will use this because you may be working with people who are not necessarily programmers, but may be helpful in the process. And therefore, by you writing it as pseudocode, then you give them the chance to understand and actually be able to interpret the code that you are going to write. So it's always important to write it in a way that it can be understood by anyone, not necessarily one who is a programmer, and therefore it should not use keywords or vocabularies that are limited to a programming language or any programming language for that instance. For example, a while, it's self-explanatory. That's why you can use a while loop. You can also use for loop because to some extent it's self-explanatory, but you can also just say repeat something n times. Okay, that is way easier for someone to easily understand. That's just an example. Yeah, so an algorithm, as I have mentioned, you may use pseudocode to represent an algorithm or before you implement it. Basically, an algorithm is an organized logical sequence of actions or approaches towards a particular problem. So how you're going to solve it, that's an algorithm. Okay, the logical process, the rules you're going to follow to solve a particular problem, that's an algorithm. Yeah, so that's why there's also this topic on data structures and algorithms. That's the point of it. It's a group. It's like something that has already been made. An example of an algorithm would be the linear search versus the binary search. So a linear search is whereby you just move from the start to the end looking. For example, you're looking for a number. You have 1 to 20 and you're looking for number 10. You would move from 1, look at it. Is it 10? No. 2, is it 10? No. 3, is it 10? No. 4, is it 10? No. Until you get to 10. So if it's 10, then you have a 10. If there's no 10, then you don't have a 10. So that's an algorithm. That's one way you could actually look at a certain string. Let's say it's a string or an array of data and you need to find a certain value. Another way you could do it is the binary search, whereby you divide it into 2. Look at this middle value. Divide 20 by 2, 10. Let's say we're looking for 6. Let's just not make it so easy. Let's say we're looking for 6. You have 1 to 20. Okay, it's arranged in a sorted way. Therefore, 1, 2, 3 to 20. So we're looking for 6. Divide by 2, 10. Is 10 larger than or smaller than 6? It's larger than. So therefore, we start with this. We just focus on the upper part. 1 to 10. Divide it by 2, 5. Is 5 larger than or smaller than? Smaller than. So we look at 5 to 10. Okay? So you see, those are two ways you solve the same thing, but the time it will take will be different. The storage amount would be different. Everything would change according to the method you've chosen. So that's an algorithm. That's two examples. We have the linear and the binary, and we also have other types of algorithms. That was just on searching. We have backtracking, among others. But that's basically it on algorithms. So an algorithm is a way to solve a problem. It can be a good way, it can be not so good way, but it solves the problem. It can also be unable to solve a problem depending on the algorithm you choose and the problem at hand. That's an algorithm. It allows you to solve a certain problem using a logical sequence that has already been designed for you to implement. Yeah, so when you're designing something like that, you can make a pseudocode first so that you can easily understand how everything works with everything else before you proceed to making it actually. And also other people can be helpful in the process, and they can tell you this is how this will work. People don't necessarily have to be programmers for them to be helpful in the process, because someone may have mathematical knowledge that is actually helpful in that process. For example, if you're solving a problem on sequence, when you're solving the problem on Fibonacci, other people can have other inputs. For example, I may do math, but when I read the problem, I know that this can be solved using arithmetic progression, and I don't do programming, but I know that. So that's the beauty of writing something in a way that everyone else can understand. Yeah, so advantages of pseudocodes. One, it's readability. It allows you to easily understand the approach you're taking, and other people too. It's also a bridge between algorithms and flowcharts that I have already mentioned. It also works as a good way to, what is this called? Documentation. It also works as a way to document your code. Then it's also, its main goal is to explain how the program should run, and therefore it should make programming easier for that programmer who is going to write the code. Yeah, the disadvantage is that, first of all, it does not have any standard. So however you will write your pseudocode, as long as it's understandable, that's what you will use. For companies, they may have different standards for their internal use, but at a personal level, you just write it how you find best, and just make it readable, understandable, and not too many keywords. We'll talk about that later. Then, similar to any other documentation, it also needs to be maintained, updated. I don't know if that's a disadvantage or just something that comes with everything else, but that's another thing about it. It has to be maintained, and it does not provide any visual logic of the program. It's just words. You're just writing it's like you're just coding, but in a way that everyone can understand. So just as indentation is important in code so that to improve readability, it's also important here. And this is just a sample. We're computing Fibonacci numbers till 50. So let me get a pen. Of course, always you need a start and an end. You declare the integers. These are the declarations. After declaration, you assign a value to each. So since it's Fibonacci, then F1 and F2 will be 1, because that's where the sequence starts. 1, 1, 1 plus 1, 2. So 1, 1, 2, 3, 5, because 1 plus 1 is 2. So Fibonacci is, you're adding, let's say we have, these are our numbers, right? 3, 4, 5, 6, 7, 8. So those are the numbers just as they are. But then when we're talking about Fibonacci numbers, we start with 1, 1. Add these 2, it will make up the next number. Add these 2, it will make up the next number. 3 plus 2 will make up 5. That's the next number. So that's the process. So we take the first one, which we have decided it will be 1. The naming will be F1. F2 will be 1 again, sorry. And so F1 plus F2 will give us the next F2, right? But the next F1 and the next F1 will be F2. That's basically what we are doing, okay? Naming should be something that is conventional, and also things that represent something else. So for example, some, just as you would do in code, some will always be for example, this f1 plus f2, that's sum. The name is appropriate for the action. Instead of just saying x is equal to f1 plus f2, a more appropriate name could be sum or add. Just something, as long as it's not a keyword. Okay, since this is not even programming, add can do, but sum shows it better. Yeah, then as I was saying before, I mentioned about looping. You could use a while loop, but this is easier to understand by anyone, saying repeat n times to mean loop, right? Instead of saying maybe while this is less than this, you just say repeat n times, okay? And then this n in our case is 50, so repeat 50 times because we want to find the first 50. Then while repeating, find the sum. F2, make it to be F1. What is in F1, make it to be F2, sorry. Then F1 will be this sum, and then you print the sum, and then you do it again. So anyone can easily understand what you mean and what is going on here. Actually, all through till here. Then we say end the loop, right? Because we were doing this over and over again, then we need to end the loop. Once we end the loop, we started the program, and therefore every program needs to end. So this is a basic example of a pseudocode. So in the case that you're writing a program, you can easily just write some basic thing when you're not really understanding what you're supposed to do. It can be a good way to think about a project before you start actualizing the code. You just think about it, think about the variables, think about the variables and everything that is needed before you start coding. So this can be a good way to just jot it down, note everything down and all that. Yeah, so that's it for pseudocode. I hope you will find it useful throughout your programming journey. And yeah, let me see you on the next one.